Good day, I am Victor Joseph Viara. Our topic is all about manual radar plotting. Course outcome: manual plotting techniques given the information from the radar observation. Learning outcomes: at the end of this session, the student shall be able to comprehend the history of maritime radar navigation, determine why radar is such valuable tool, recognize the ship parameter. Importance of the topic: the student can perform manual plotting techniques given the information from the radar observation. So, history of radar. New technologies of radar became available to merchant shipping with the end of hostilities in 1945. Radar on merchant ships was initially installed for commercial purposes on ferries to maintain better schedules in fog and large fishing vessels. Radar was treated with great suspicions by the mariners. With improving technologies and after some time, the use of radar for safety purposes was recognized. Misinterpretations of radar information had not resulted in any reductions of the number of serious collisions at sea. International Conference on Safety of Life at Sea in 1960 revised the international regulations for preventing collision at sea by adding rules to take account of the use of radar and recommendations on the use of radar informations as an aid to avoiding collisions at sea. The International Conference on Safety of Life at Sea in 1974 adopted provisions to the SOLAS conventions making radar a mandatory carriage requirements for merchant ships in a peace program starting in 1980, which finally completed in 2002. SOLAS requirements: all merchant ships of 300 gross tonnage and over now shall carry a radar, and many carry two IMO adopted performance standards for marine radars, which are used in connections, integrations with other navigational equipment required to carry on board ship, such as an automated target tracking aid, ARPA, IAS, ECDIS, GNSS, and others. Non-SOLAS ships: many small craft also carry radar voluntarily as manufacturers have produced cost-effective design for their needs. The shipmaster point of view. The key facts are that radar remains and will remain the primary systems for collision avoidance, and radar is very important for navigation. That is all. Thank you.
Good day, I am the Cadet Alolod and I am the next reporter to discuss about the why is radar such a valuable tool. So, the master and watchkeepers have confidence in information radar provides because its operation is ship-based. It's not reliant on third-party sources. It has a proven track record. Radar is useful with SARTs when engaged in search and rescue. In short, in its display, radar offers the watchkeepers the basic reality of the targets relative to the ship. It therefore aids the watchkeepers and helps in decision making for both navigation and collision avoidance. Collision avoidance early action is required to avoid a close quarters situation, therefore, early identification of closing targets is essential. Watchkeeping officers need to be competent in the use of radar and are trained in its use and the application of ARPA. Some IMO requirements: maximum emergency stopping distance from full speed of the ship should not be more than 15 ship's lengths. Emergency turn radius of the ship should not be more than 2.5 ship's length. Ship parameters: emergency stopping distance 3.3 km to 5 km, or in nautical mile 1.8 nautical mile to 2.7 nautical mile. Emergency turning radius 550 meters to 840 meters, or in nautical mile, 0.3 nautical mile to 0.45 nautical mile. And lastly, the displacement weighs 100,000 to 250,000 tons. Practical requirements. To start plotting targets and determining their course and speed when the target is between 8 and 10 nautical miles off. Navigation. Radar gives accurate information on distance from charted futures and assists in maintaining the ship's course. Radar will normally show a 60-meter high and landmass at a range of 20 miles. This is considered by seafarers as a minimum requirement. So this is the example of my topic. So that's all. Thank you.
Good day, sir. This is the Cadet Jonard Agokoy. So the next slide that I will discuss is the Resolution MSC 19279, which has a table of target description, height above sea level in meters, X band in nautical mile, S band in nautical miles, which has the shorelines racing to the shoreline, which has height above sea level in rising to 60 meters. The X band is 20 nautical miles. The S band is 20 nautical miles. The shoreline, which has height above sea level of rising to 6 meters. The X band is 8 nautical miles. The S band is 8 nautical miles. The shoreline, which has height above sea level of rising to 3 meters. The X band is 6 nautical miles. The S band is 6 nautical miles. Solar ships which have greater than 5,000 gross tonnage, the height above sea level is 10 meters. The X band is 11 nautical miles. The S band is 11 nautical miles. The solar ships which has greater than 500 gross tonnage, the height above sea level is 5.0 meters. The X band is 8 nautical miles. The S band is 8 nautical miles. The small vessel with radar reflector meeting IMO performance standards with height above sea levels of 4.0 meters. The X band is 5.0 nautical miles. The S band is 3.7 nautical miles. The navigation buoy with corner reflector with height above sea level of 3.5 meters. The X band is 4.9 nautical miles. The S band is 3.6 nautical miles. The typical navigation buoy with height above sea level of 3.5 meters. The X band is 4.6 nautical miles. The S band is 3.0 nautical miles. The small vessel of length 10 meters with no radar reflector with height above sea level of 2.0 meters. The X band is 3.4 nautical miles. The S band is 3.0 nautical miles. So the next slide that I will discuss is the discrimination of targets from watchkeeper's perspective, which is to be able to distinguish a tug from its tow at sea at 12 miles range, and approaching a rig on a supply vessel to clearly identify the standby boat from the rig at 6 miles range, and to be able to distinguish the anchor pennant buoys of a semi-submersible rig at 3 miles range. So you will see in the slide a tugboat which is engaged in towing. So the next that I will discuss is the resolution MSC 19279. The range, which is the radar system, should be capable of displaying 2-point targets on the same bearing, separated by 40 meters in range as to distinct object. And the bearing is the radar system should be capable of displaying 2-point targets on the same range, separated by 2.5 degrees in bearing as to distinct object. So you will see in the slide a picture of radar, which you will see the range and bearing.
So thank you Agokoy. So for the continuation of our report, so navigation. So radar greatly assists navigation during poor visibility. So pilots rely on radar at close range and reduce visibility to pass buoys and beacons. So the minimum range is 5.4. So 5.41 with on-ship at zero speed, an antenna height of 15 meters above the sea level, and in calm condition. The navigational buoy in table 2 should be detected at a minimum horizontal range of 40 meters from the antenna position and up to a range of 1 nautical miles without changing the setting of control functions other than the range scale selector. So in engineering terms, RES, the TU are M1313, power 30 to 70 kilowatts. So horizontal beam width 0.75 to 4 degrees. Pulse width 0.00 1 decimal 2 microsec. PRF 4000 375. Noise figure 3 equivalent to 8 dB. So our antenna here is pitch 3 degrees, roll 25 degrees, yaw 5 degrees. So vertical beam width 20 to 30 degrees. So that's all of for our topic. So thank you.